Nyałajskano, Kristen Kazak. I am Seneca Hawkland in Polish, and I wanted to welcome you to the workshop this evening. Thank you for joining us. I know many of you, I've heard from many of you, but I work on Buffalo Commons, which is the joint collaboration between Cornell ILR Buffalo Collab and Partnership for the Public Good. Many of you are familiar with PPG. It's a community-based think tank with over 320 different partner organizations. I wanted to welcome you this evening to Protections Needed for Western New York during the demolition of the most radioactive building at West Valley, featuring our folks and friends from the West Valley Action Network. This network formed as individuals and groups in 2009 to work for the full cleanup of the West Valley nuclear waste site in West Valley, New York, Cattaraugus County, draining north into Erie County and the Great Lakes. It's comprised of individuals and organizations in New York, the US, and Canada working for the full cleanup of the West Valley nuclear waste site. It includes Coalition on West Valley Nuclear Waste, Sierra Club, Western New York Environmental Alliance, Nuclear Information and Resource Service, Indigenous Women's Initiative, Citizens Environmental Coalition, Western New York Peace Center, Wingkosh, Citizens Campaign for the Environment, Adirondack Mountain Club, religious groups, sporting groups, and many, many more. This is the third in a series of about 6 going over the history and actions needed regarding West Valley and its cleanup. We'll share more about the previous and future workshops, including links that we'll put into the chat towards the end of our conversations today. Just some logistics. If you need closed captioning, you should be able to navigate to the bottom of your Zoom screen and select that for a live transcript, if that is your preference. Just in terms of logistics, we'll hear from both of our speakers tonight, and then they will answer questions after both of them have been able to speak. If you have questions while they are talking, which I know you probably will, you are encouraged and welcome to type in the chat any questions as they come up, and we'll refer back to them at the end of the presentation. Today, we're going to hear from Dr. Charlie Bowman and Diane Dorigo. Diane Dorigo is the Radioactive Waste Project Director at Nuclear Information and Resource Services. She has degrees in chemistry and environmental studies, and work history and analytical and organic chemistry, with a focus on pollutants in the Great Lakes. She's worked for the Sierra Club Radioactive Waste Campaign from 1980 to 1984, and is a community organizer and researcher at other public interest and environmental groups. Dr. Charlie Bowman is on the board of the Western New York Peace Center, chair of the Environmental Justice Task Force, and its center's past director. He worked as an assistant professor at the University of Buffalo. So without further ado, I'm going to pass it over to Diane to get us started.
Thanks, Cricky. I'm Diane Dorigo, Nuclear Information and Resource Service, and also part of the West Valley Action Network. And this is the third in the series. The first 2 parts went over what's at the site, and I'm going to touch on that with a few pictures, but mainly we're focusing tonight on the demolition of the main plant process building where reprocessing took place. So this is an overview of the site. A lot of the buildings have since been demolished, but the big one is yet to come. Let me just see if I've got the, it's not forwarding. Let me see. Oh, there we go. So West Valley is located about 35 miles south of Buffalo. It's upwind of most of New York State, of Canada, Pennsylvania, Ohio, depending how the wind blows, and to states to the east and the northeast. It's about 20 miles upstream of the Cattaraugus territory of the Seneca Nation of Indians. And the site is cut by streams and creeks that drain into the Cattaraugus, which goes into Lake Erie, Niagara River, Niagara Falls, and Lake Ontario and beyond. This is another view. The circle in the middle is the West Valley site, and you can see it's just south of the Cattaraugus Creek. The creeks at West Valley run into that, and then it runs through the Cattaraugus Reservation into Lake Erie. This is an overview of the West Valley site with some of the creeks and the flow is from the bottom to the top. So the streams drain from the West Valley site up into Buttermilk Creek, which down the pike merges with the Cattaraugus Creek. It runs through Zoar Valley, beloved recreational area. It would go past the intakes on the water supply for Erie County and the Seneca Nation. It goes right past the waterfront. This is Geo Professor Dr. Mike Wilson, a geologist, geophysicist from University of SUNY at Fredonia, and he did a report, was part of a report that concluded that it'd be better to clean the site up sooner rather than later, especially because of the erosion. And again, you can just see that the site there is upwind and upstream of a lot of other places, so it matters what happens there. I wanted to point out that at West Valley, there have been off-site releases of radioactivity into the air and into the water, and some of the most well-known ones are plutonium that was released during reprocessing and believed to have traveled through the waterways into Lake Ontario and was reported on through reports by Joshi and others. The radioactive iodine 129, this one is not as well known, a study done by University of Rochester researchers, Fen Rao and others. They found there were higher levels of radioactive iodine 129 throughout Western New York and attributed that to West Valley, not to bomb testing. There's a cesium plume. Let's see, the cesium prong is what it's referred to from a blowout of the stack during reprocessing in 1960s that led to contamination of an area which I'll have a map of to the north of the site. And the strontium plume, radioactive strontium migrating underground, is migrating through the groundwater into the surface water and downstream, but a wall has been put in to filter much but not all of that radioactivity. There are other locations that have had off-site releases during their demolition, during their decommissioning. Two of those are Hanford, Washington, and Spru, a facility that Charlie will talk more about in Eastern New York. The same companies that are cleaning up the West Valley site are the ones that were working on these two sites when there were off-site releases into the air. And we're concerned that we don't want to repeat those mistakes. Certainly the companies have learned some lessons and will do their best to not have such releases. But part of our call for monitoring and for an enclosure is to make sure that there are not releases. This is a complicated looking overview of the site from the decommissioning report by the decommissioning plan. The yellow spot on the top there, that is the strontium plume, and then the coral or orangish color area to the left, at the upper left of the map, that is the cesium prong. Radioactivity did get off-site from activities at the site. This is another view of the prong. The pink or red part is the West Valley site, and north is to the left. So the cesium prong was to the northwest, is to the northwest. We've looked at, it's possible to look at which way the wind blows. So if there were releases, the one on the left is at 10 meters, the one on the right is at 60 meters. This is the way the wind primarily has blown as of 2019. And so we have concerns that if radioactivity were to be released from the site, that it would spread in these various directions. So what's at the site right now is long-lasting hazardous and radioactive waste. Some of it is dangerous now and will be for millions of years. It's in holes in the ground, trenches, tanks, underground, and it's also in above-ground facilities and in those plumes and streams that we talked about. This is an overview of the site. As you can see on the right, there's a plateau, middle top there. There's a plateau with a lot of structures. A lot of those structures now have been taken down, but that's where the reprocessing building is, the MPPB, main plant process building, which is slated to come down in 2021, possibly as soon as December, and into 2022. It'll take a while for it to come down. On the left are the burial grounds. The black topped area are the state licensed trenches, and then there's a brown area that is the federally licensed burial holes, and then beyond that toward the road to the top to the north is where the high-level waste canisters are now stored. Burial was done in unlined trenches. They had to put liners over the top to prevent water from getting in and spreading the radioactivity. The holes in the ground have some high-level waste in them, and we're in somewhat of a concern, I would say, that the federal government does not want to clean up that burial ground. The state licensed burial ground would never be a federal responsibility. That's going to be up to New York to prevent from, to dig it up and recontainerize it. The main plant process building, or the reprocessing building, is 40,000 square feet. It's got 55 rooms. The dose rates in those rooms and cells is up to 2,500 millirems per hour, and that's a high amount. It's 5 stories high. The walls are anywhere from 2.5 to almost 6 feet thick. There are 4,000 feet of piping. The building goes below and above grade. We're looking now at removal in this coming project of the above ground portion. And this is one of the hottest radioactive buildings in not just the most radioactive one at West Valley, but potentially in the nuclear power and weapons complex, because it brought in the hottest part of the fuel chain for reprocessing. The fuel chain includes, it starts with uranium in the ground, which is not that concentrated. It gets concentrated through various steps, and then the uranium fuel is made into rods and then assemblies, which go into the core of nuclear reactors. And so the pellets are stacked in 10 to 14 foot long rods, a couple hundred rods per assembly, a couple hundred assemblies per core of the reactor. And it stays in that core for in the range of 3 years. And then it comes out millions of times more radioactive than when it went in. It went in as mostly uranium-235 and some other uraniums, and it comes out with a whole array of radioactive elements that the uranium split into or formed, including plutonium, cesium, strontium, and iodines. So the fuel, when it comes out of the pool at the reactors, is so hot it has to stay in water, water-filled pools for a while, and then it can be stored dry. That fuel was brought to West Valley, which did have a fuel pool, and was brought into the fuel pool there. And we've got about 90,000 metric tons built up around the country. And the reprocessing experiment at West Valley really shows that that's not a good thing to do with the fuel. So we've got to do something else to try to isolate it as long as possible. The reprocessing that was done in the building and the cleanup has had to be largely done by remote control because it's so hot. And there's been terrific work done by the contractors of cleaning out that building. However, there still is radioactivity remaining. So what they did there was to bring those fuel rods, chop them up, dissolve them in chemicals, and extract uranium and plutonium, and then the liquid and sludge went into these underground tanks, which later were drained to convert the liquid into a solid, and the solid logs are now in dry storage on the site, but the radioactivity is still encrusted in these underground tanks and needs to get exhumed as well. And this is a fight that New York and the public are going to have to make sure that those get dug up. So the canisters, the logs that were formed from the liquid from reprocessing have been put into casks and are on the site. The reprocessing took place from 66 to 72. there was only a year's worth of fuel reprocessed in that time. There were a lot of high worker exposures and leaks to the environment. And as I mentioned, that cesium prong is because of a blowout. It's been a big success, though, that the liquid has been converted into solid. And as I said, the activity has largely had to be done by remote control. And we're at the point now where a lot of the building has been cleaned out and the materials sent to nuclear waste sites in other parts of the country. The demolition now of this building is going to take place, and it's important, we believe, to monitor off-site as well as on-site. On-site is certainly happening, but off-site to see if anything gets out. This is a view of the high-level log storage area in the casks that are near the road at West Valley on the South Plateau. Monitoring that needs to be done as of air and water, on-site and off-site. We would like the reporting to be done to the public and possibly to the state agencies. We need to put pressure on our state officials to direct our state agencies to get more involved and have more oversight over what's happening. The Environmental Protection Agency has some authority, but we've not been able to identify a strong interest by EPA or the state agencies are pretty much letting this demolition take place without a lot of oversight. Since there have been releases in the past, both at the site and at other sites where these same contractors were, we would like to have independent monitoring or monitoring that the state would also have an eye on if the Department of Energy were to do it. And we would like it to be real time rather than the current system, which takes monitoring samples around the site and then reports them a year later. And they only take them at 16 compass points at chest high monitors. We would like them to be at various levels in the primary directions of populations and schools and such, so that we are able to identify not only alpha, beta, gamma, but also radionuclide specific. So the request is for real-time, constant monitoring, and if there need to be sampling, that the lab analysis be done quickly with routine reporting. These are our main asks as of 2021 is before, during, and after the demolition, that there be real-time reported air monitoring, and we would like water monitoring as well off-site, radionuclide specific, with state oversight, independent oversight, and monitoring, and enclosure of the facility during the demolition. And I will turn it over to Charlie to talk more about demolition. And then I'd like to, let me just see if I had something else here. I have some slides on radiation that I can share if we have time after Charlie's presentation. And I would just share the major concerns at the site right now are the dispersal of radioactivity into the air, erosion, cracks, and especially with climate change, radioactivity getting out from the buried areas, from the underground areas, and also climate change. In the studies being done, climate change is not being taken seriously. There are geological concerns, and there are political concerns regarding the upcoming. This is something we'll be talking about in future sessions, is the supplemental environmental impact statement that will be coming up for public input in 2022. And the studies that are currently being done in a black box, we're not being allowed information on some of the basic assumptions being put into studies and computer analyses that will determine the long-term condition of the site. But in the meantime, the immediate physical concern is the demolition and what we need to do to protect Western New York during that. So I'll turn it over to Charlie Bowman of the Western New York Peace Center.
Okay.
Unshare here.
Okay. Trying to get my my screen going here. There it is. Okay, is that being shared now or?
Yep.
Okay.
And you can do it full screen next to the minus sign there.
There we go. All right. My name is Charlie Bowman. I'm a retired assistant professor at UB. I'm also retired from the board at Western New York Peace Center, but I continue as their chair of the Environmental Justice Task Force. And I'm also chair of the Western New York Drilling Defense, which is an activist group located in Buffalo, New York. So I came on to the West Valley issue about 4 years ago at the behest of Linda Sneekloth. I tried not to do it, but she convinced me to get into this issue, and there's an enormous amount of paperwork involved in West Valley and also other sites around the country. And so it's overwhelming. The information is just overwhelming, and my hat's off to the other people who have followed West Valley for many, many decades, Ray Vaughn, Joanne Heimister, and Diane Dorigo. It's an amazing, consistent effort on their part. I'm going to focus on a tiny issue here. It's not a tiny issue, but a very limited issue. I'll be trying to convince everybody why we should make this demolition and an enclosed demolition. The building must be enclosed before demolition. I hope to give you some factoids on why that needs to be done. I'm going to be talking about the history of the Knowles Atomic Power Laboratory. That was built way before West Valley. Knowles Atomic Power Laboratory in Niskayuna, New York, was built in the late 40s and came online in 1950. And it did research on Purex method and the redox method of separating plutonium and uranium from spent nuclear fuel. Spent nuclear fuel, as Diane said, is fuel used in power reactors that is no longer efficient at generating heat. And so the unfortunate thing is they only burn up 2% of the fuel, or 1 or 2% of the fuel, before that situation happens. And so there's an enormous potential waste of plutonium and uranium still within that fuel. And so there was a huge driving force early on to figure out how to extract the plutonium and uranium from spent nuclear fuel, because it's very expensive and time consuming to get those elements in the proper shape for power reactors. And so anyways, they did the basic research, the early basic research on the Purex method, which West Valley eventually used, was done at the Knowles Atomic Power Laboratory in Niskayuna, New York, between those 3 years. Now, after 1953, the research on extraction, separation of plutonium and uranium was transferred to Hanford and to the Savannah River site. So the Knowles Atomic Power Laboratory just worked for 3 years. And so since 1953, it sat idle. And you can see here, it sort of sits east of Schenectady, New York, and northwest of Albany, New York, on the banks of the Mohawk River. So here's Capel, Knowles Atomic Power Laboratory, sitting on the beautiful Mohawk River. And there's two buildings involved. One is called H2 and another one is called G2. These are the buildings where they carried out the separation research. And so I did some Google research, Google Earth research, and here's a picture of it in September 2009. The separation process unit building H2 and G2. And you can see in July 2020, they're gone. And the story of how they came to be taken down is really relevant to the situation at West Valley. So they operated between 1950 and 53, and they did research on the Purex and Redex method. And then after that, they closed it down. And so it wasn't until 2008, 2009, 50 some odd years after the closure of the research, separations research at Capel, that they decided to take it down. And they decided to take it down in a very short time. And sadly, a series of events happened which spread radioactivity. So basically, the story is they did open air demolition of building H2, part of H2. They don't show the whole entire building here, but a significant portion of building H2 was taken down in the open air. They discovered pretty soon afterwards, they spread radioactivity around the area. And amazingly, they were doing demolition of this radioactive building the day before an expected rainstorm. And that rainstorm over the next 2 days was later termed as a 100-year rain event, and it spread the radioactivity even more. So, but here's a picture of it just 5 days before the rainstorm hit. And they knew the rainstorm was coming, and they probably didn't realize what the intensity was going to be. But certainly on the weather tracks, even before this slide, you can see it moving up northwards. This is called Tropical Storm Nicole. And Tropical Storm Nicole dumped 7 inches of rain on 6 or 7 inches of rain in Albany and Schenectady and parts beyond those. So, here's the sequence of events. So they demolished the stack on H2, which I'll show a picture of in a minute. And on September 29th, they took down several other structures on building H2. And then the wrecking crew broke for lunch. And by the way, this time sequence came from DOE investigation afterwards. And the citations are in my slides here. But anyways, they broke for lunch and the radiation alarms go off on 4 workers. 4 workers had 11,000 counts per minute on the heel of their boats. That's an enormous amount of radiation. So they hit the panic button, so to speak, and Capel just deployed 60 workers to survey the entire site for radiation. They also knew that the next day they were going to get a ton of rain. So the workers were directed to spray glue on the H2 debris pile. That glue will be likely the same glue that, or a very close cousin to it, that West Valley is going to use to limit the spread of debris. And anyways, here's the glue. So the workers were directed to spread the glue on this pile of mess here. And you can well imagine that the glue cannot get into every nook and cranny in this pile of debris. They can only get a fraction of, they can only immobilize a fraction of the debris here. So this was an accident waiting to happen, and it did happen. So they sprayed the glue on the pile, and but the next day they got that 100-year rain event, the 7 inches. And not only that, but a receptacle frac tank, which collects groundwater from underneath the building, which also contained radioactive water, overflowed. it went into the river, I believe. And the air monitors around the site recorded increased radiation. So after the rain, the radiation surveys counted 500,000 counts per minute to 1.5 million inside the debris pile. So clearly there's a lot of radioactivity there. So what's the best thing to do? The only thing they could do was to cover the debris pile with tarps. And there it remained for 2 years. But unfortunately, less than a month later, they had another rainstorm coupled with a sump pump failure. And those two situations combined to release 640 gallons of radioactively contaminated water into the Mohawk River. And that headed downstream towards the intakes of Latham, New York, and to Cohoes, New York, which gets their water from the river. The town supervisors were not notified immediately, which caused some consternation. And I won't go into that. But anyways, in the aftermath, there was an investigation, and by the fall of 2012, they decided to enclose. They did what we're asking for at West Valley. They enclosed building H2 and G2, which the combined footprint is a little bit smaller than the main plant processing building at West Valley. But anyways, they did what they should have done in the beginning and enclosed the radioactively contaminated building with polyethylene tents. And finally, over the next 7 years, they worked inside those tents to gingerly take out chunk by chunk in a careful manner the remaining structure of the buildings. And those buildings are now gone. The ground where they were is now decontaminated, and apparently everybody is safe. So so the lesson here is that, they did open air demolition on the day before the impending tropical storm. And the second thing that bothers me is that they didn't have a meteorologist on staff to say, how bad was the storm going to be? What should we do? Should we wait? Should we cover it with tarps? They didn't have a professional meteorologist to talk to. So that's what I'm asking for West Valley. They should have a meteorologist on staff during the demolition process. The intensity of the rainstorms are in the summertime are increasing around the world. There's now a growing library of videos of showing rain bombs, and if you Google rain bombs, you'll get a wonderful collection of a scary collection of videos. And I recommend you take a look at the rain bomb that was photographed over Phoenix, Arizona in 2014, on the Washington Post. So if you use those terms, you'll find it. It's a scary thing. And they do a lot of destruction on the ground by wind and water. So the intensity of the rainstorms are increasing. So we need to do everything we can to protect these sites. And the best thing we can do right now is to enclose these sites prior to demolition. So this is what they did after, after the horses left the barn, so to speak. They covered this with tarp, but there's obviously more radiation in there to protect. So that's a good thing. It's a good thing that they did. Why they didn't do this the day before the rainstorm, perhaps they didn't talk to a meteorologist. Anyways, this is October 2010, and this is what it looked like, remained until they built the tarp, the tent, the enclosure over. This is the demolished part of the building, and there's also an erected, the part of the building is not demolished. So this is just this gives a limited view of what actually is present there. Anyway, so here's what building H2 looked, and the part that they demolished in the previous photograph was something on this order where I'm showing my, I don't know if you can see my mouse or not, but it's on the right-hand side where that smokestack, so to speak, is. So the rest of the building remained intact. And after they built the tent, so here's the tent covering the whole structure. So they erected a steel frame around this this building, and they also did one for building G2. This is H2, sorry. And the important thing about the tent is that it's under negative air pressure. All the air in that is at less than atmospheric pressure. So any leaks in the tent, the air from the outside will be leaking inside. And the way they can maintain that suction, so to speak, is through pumping air out into the atmosphere, but through HEPA filters, which are very, very good. They're the gold standard for particulate filtration, down to less than a micron in size. So this is this negative air pressure combined with the tent structure is what should happen at West Valley before they take the building down. Now here is building, I think, I can't see. I think this is G2, yeah. So this is G2 before demolition, and then G2 with a enclosure. And here's another view of that. So anyways, that's what should happen. They also published an inventory, a radiological inventory of what was inside the building. These elements, the strontium, cesium, plutonium, and americium, they are common to West Valley too, although the radiological inventory that we have access to, which was published in 2010, lists many more, and I'll show you that in a minute. But it's a puzzled me that there's not more here, because they were doing essentially what they were doing at West Valley. So there should be, if you take spent nuclear fuel and dissolve it, you're going to get a bunch of other fusion products. So this is a very limited list, and I suspect it's highly limited. So, but anyways, the total curies at site, which caused all this consternation, was only 35 curies. And for West Valley, as of 2010, here's what was published in there's a live link down on my slide here, table 4.4-5, and we're dealing with over 6,000 curies as of 2010. Now, at the quarterly public meeting at West Valley, they keep saying that they are removing radioactivity inside the building, and I hope that's certainly true. And but they don't give us an inventory as such as I show here. They claim as of February of 2021 that they removed 98% of the radioactivity in the main plant process building. So here's my, there's a thing here I can't see here. Oh, there it is. Okay. So the main plant process building has 6,100 curies. As of 2021, they're not advertising. They're not letting us know how many curies are in the building. The approximate area of the building is roughly 24,000 square feet, guessing from Google Earth. And the building will not be enclosed prior to demolition. Now, the Knowles Atomic Power Laboratory, the combined footprint is close to that. It's 21,000 feet. So they're comparable in size, at least the combined area. And both buildings were enclosed prior to demolition. Now, we don't know how many curies are inside the building. So they can close, they say is 98%, and I'll show you in a bit that even that is of concern. It's there'll still be curies in excess of what was at Noel's Atomic Power Laboratory. But anyways, the radiation dose limits that that they are working towards at West Valley, that the average person will receive less than 10 millirems per year per person, and I don't know how to get I've never understood how to get my head wrapped around that, because what, I do some reading, and millirems is energy deposited in a tissue, per gram tissue or per unit volume. There's multiple ways of doing it, and so I don't know what that means, but many the problem is that many of the radioactive nuclides at the main plant processing building are alpha emitters, and they are dangerous if they get inside your lung. Plutonium, for example. And so if a person breathes in a tiny particle of plutonium, all that energy will be deposited within a small area within or surrounding that particle in your lung. And that's an enormous dose. It's not 10 millirems. It's much, much greater than that. Orders of magnitude greater than that. And the way they get the 10 millirems energy deposition in your body is that they assume that all the pollution will be averaged over your body. But in reality, if some dust particles escape from West Valley, as they certainly will do so, and they have never claimed that they will capture everything at West Valley during the demolition, people take breaths, and most of that escaped radioactively contaminated particles will be deposited on the ground as part of rainfall, perhaps rain deposition, or some of it may be breathed in, maybe taken in by someone's next breath. So, and once it becomes lodged in the lung, plutonium doesn't leave. It stays there for some time. So, and it's depositing all that energy in a small volume. So this 10 millirems per year per person is very misleading, in my opinion. And I want to put some numbers on that. So what are the potential dangers of tiny amounts of radioactively contaminated dust escaping from the demolition during the demolition of the building? So the experts in the field over many decades of research have come up with the idea of an overdose where you have an excessive risk of cancer over a lifetime, and the experts have more or less agreed on that number. I won't tell you here what it is, but that's a certain threshold. And it turns out, through the work of Dr. Gordon Edwards, who has done wonderful work, who is a Canadian expert on radioactivity, has been following the issues since the 40s, I think, or the 50s. And he has an interesting way of approaching this idea of getting to the overdose limits of dust particles. So it turns out that if 0.1% of the mass of plutonium, that's in the 2010 inventory, which is out of date, at West Valley escapes during demolition, how many people could this place at risk of overdose if all of that plutonium was breathed in by millions of people? It turns out that number, that amount of plutonium could potentially increase the risk of cancer to beyond the lifetime limits, beyond the limits of what it should be. So that's a tiny mass of plutonium. And that's the worst case scenario, of course, which will not happen. But it turns out that this stuff will be in the environment for a long time, and it could potentially contaminate people for many generations to come. If they come into contact with it in the environment where it's polluted. So just a tiny amount of radioactively contaminated dust is toxic to humans and other biota. Here's the calculation which that is based. I won't go into that, but if anybody wants, it's a very simple calculation. But anyways, to sum up, to finally wrap this up, I think the DOE is removing radioactive contamination inside that building, which is exactly what they should be doing. They won't give us the inventory. We have repeatedly asked that they do so, but they have repeatedly not given us the inventory. But anyway, so I don't know, I don't have a starting figure to give you, but let's assume that the DOE removes 99.9% of the plutonium-239, which is just one of the alpha emitters in that building. And that if they remove 99.9, they're doing a good cleanup job. I would hope that was good, and that sounds good. But the remaining plutonium from that 2010 inventory, at least, there'd be still 1 gram left. So if they do the 99.9% cleanup, there would be less about 1 gram of plutonium left just prior to demolition. Now they do the demolition, and suppose that only 0.1% of that escapes from the building. So 1 milligram, 1 milligram is a tiny amount of mass. It's hard to measure that on a laboratory scale. 1 milligram. You have to be careful. And but that tiny amount of mass is enough to overdose 10,000 people. In other words, give them an excessive risk of cancer over their lifetime. So plutonium is extremely dangerous because it's an alpha emitter, and it has a long half-life of 24,000 years. And it doesn't end there after it decays. Unfortunately, it goes into U-235, which has another half-life of 700 million years. And the radiation experts tell us that you need 10 half-lives before radiological, plutonium or any other form of radiation becomes radioactive particle becomes safe. So we come out with a horrific number that West Valley, any plutonium escaping from West Valley into the environment will remain toxic for at least 7 billion years. To put that into perspective, Earth is only roughly 4.5 billion years. So it's a plutonium that they've made over the past 60 years is forever toxic wherever it is around the world. There's a ton of it around the world. And it's forever toxic. We don't know how to shut off the radioactivity. And as Dr. Gordon Edwards has said repeatedly, we now live in the age of radioactive waste, which we can't escape, So anyway, here's what they asked.
Go back, you said plutonium in the 7 billion, you meant uranium. The plutonium's 1/4 to 500,000. I mean, your slide said it, but I think you just juxtaposed plutonium and uranium.
Okay, all right, thanks.
Okay. Sorry.
And so what they asked, we should ask our elected officials to force DOE to build an enclosure around the main plant process building at West Valley prior to demolition. And DOE should have a meteorologist on site during the demolition to warn of any impending meteorological events that may affect spread of radioactivity. And of course, we need to ask for offsite monitoring, as Diane has pushed for. So thank you.
Great. Thank you, Charlie. Thank you, Diane. We wanted to open it up to folks to ask questions of Diane, of Charlie, of any of the things that they have shared, of any of the recommendations that they have for folks. One question that I know people have asked is, with your recommendation to target our elected officials, are there certain elected officials that should be targeted more than others? Are there different levels of government that need to be targeted? Are there different messages that need to be brought to them? What can people do and where can they focus their efforts?
Do you want me to go? I put into the chat a link to a letter that people can send. It's a form letter that would go to the governor and lieutenant governor, so Governor Cuomo and Lieutenant Governor Hochul, and to your assembly person and your senator in New York. Really, New York does have authority. States have more authority than many of them assert. And New York could be asserting more authority over what's happening at West Valley. There's a fine line because New York wants the federal government to do as much of the cleanup as they'll do, and they don't want to hinder it. But we're talking about potential spread of plutonium, uranium, and other isotopes around our region, which would be essentially a permanent contamination. So the pressure for New York to get our state agencies to do or to participate in offsite monitoring is going to have to go to whoever controls our state agencies, and that is Governor Cuomo, and that is the New York State Assembly and senators, and particularly the chairs of the environment committees in the Senate and the Assembly, and the majority leaders in the Senate and the Assembly. So the pressure needs to be on our state officials now to learn about and know what's going on. And West Valley is upwind of most of the state and upstream of the whole northern part of the state. So we should go after our state officials on better oversight. And then we need them to be pushing DOE. And then we need to go to our federal officials, which would be our senators, our 2 senators, and each of our representatives, to call on the federal government, to the Department of Energy, to do this offsite monitoring. They've got the equipment to do it, but they don't want to put it toward West Valley, and they don't want oversight. So the pushes need to be on our elected officials, particularly the governor and the state elected legislators, and then on the federal level on the senators and representatives to make these things happen. And there's also been suggested that we should have our federal officials require that New York and the Department of Energy enter into some kind of negotiation so that there's reporting on the monitoring that they are doing. Right now they're planning to do monitoring on site, which is great, but there's no reporting of that to anybody in the state that we know of on a routine basis. It would only be if they decided that there was something that they needed to report, like they did at Knowles. But in the case of the Hanford release from the Hanford plutonium finishing plant, when these same companies were demolishing that plant, it was the state independent monitors that detected plutonium. And at many locations, the Department of Energy is not forthcoming with what it has released. In fact, at West Valley, they wouldn't know what they've released offsite because there is nothing offsite other than chest high monitors that have filters that are collected every few weeks or few months. So state elected governor, assembly and Senate leaders, and federal representative and senators.
Great, thank you. There are a couple questions in the chat. The first one is from Joanne. The tent at Knowles must have ended up being radioactive, yet another stage of waste. How did they go about handling that? So that one might be for Charlie.
You're on mute, Charlie.
Okay. I'm trying to read the question again. I'm sorry.
Yeah, the tent at Knowles must have ended up being radioactive, which seems like another stage of waste. How did they end up handling that?
Well, it's polyethylene, and they must have packed it into a container, and the radioactivity would be trapped in there, and it would be trapped on the filters that are maintaining the negative air pressure. And those filters would be disposed of in manners that Diane Dorigo could answer better than I. But it's better to trap the radioactivity in filters or on surfaces of polyethylene than it is to let it escape into the surrounding community and environment, where, as I pointed out, it will last. The plutonium, at least, will be there forever. And so that's, maybe Diane can talk about where they take the material.
Yeah, so theoretically, if it was radioactive waste, it wasn't, the only thing that's high level waste is irradiated fuel, the liquid and sludge from reprocessing, and the solid they convert it into. Everything else, unless it's over 10 or 100 nanocuries per gram, is considered, quote, low level waste in the US. So it would have gone to either the Department of Energy's waste site in Nevada, or there's a commercial energy solutions waste site in Utah. And depending what year it was, I don't know if this was before the waste control specialist commercial site that does have huge DOE capacity for Department of Energy waste, in waste control specialist site in Texas. So waste control specialist Texas, the DOE site in Nevada, or the energy solutions site in Utah would have been where, if it were considered, quote, low level waste, it would have gone for disposal.
Great, thank you. Another question from the chat is, where does the 99% plutonium go? Is that blocked, and how are they kept safe from making contaminations?
Well, they're cleaning up. They haven't advertised that they cleaned it to 99% yet. They advertised in February of 2021 that they cleaned out 99% of the radioactivity. Again, we don't know. They haven't given us an inventory, and we've repeatedly asked for that inventory. So but they've cleaned out 98% of it. And again, Diane may be able to tell us where.
Yeah, this is a Department of Energy operation. So the Department of Energy has access to those three sites that I mentioned: the Nevada, the Energy Solutions in Utah, and the Waste Control Specialist in Texas. Those are licensed. The last two are licensed commercial radioactive waste sites that can also take Department of Energy waste. So that's where DOE sends its waste. They might also possibly have sent it to processors to mess around with it, but the ultimate destination, if they send it for disposal, is to those three locations. And what they were doing there is going into the building first by remote control and cleaning out all the stuff that was left over. I had a couple of slides that were kind of yellowed, and it showed barrels and boxes in that were like originally behind leaded glass. So that it was a monumental job. We have to give lots of credit to those workers that are going in there and clearing out the remnants from the 6 years of reprocessing, and it's taking more than 6 years to clean it all up. And what they're doing is taking it apart and packaging it and sending it off to, unfortunately, it's just burial in other parts of the country and moving it on roads and rails and waterways. But hopefully those places won't leak as fast as the West Valley site would.
Great, thank you. Another question that we have is about those who would be impacted. I think it was Charlie who had mentioned there could be potentially even 10,000 individuals, even with that small amount. Do you all have a sense of, and this might connect to some of your previous presentations, have a sense of if there are certain groups, communities, or individuals who would be impacted based on their proximity to the location, or is it really just open to anyone based on where the water flows or where the wind blows that day?
Well, it's where the water flows and where the wind blows will determine who's going to get affected. Now, just immediately southeast of of the site is West Valley itself. I don't know the population of that, several hundred people perhaps. To the north is Springville. Again, a short distance north, there's maybe 1,000 people there. To the northwest is the Seneca Nation. Maybe 10,000 people live on the Seneca Nation. Maybe Agnes can tell us, maybe. But those are the at-risk, immediately at-risk populations, depending upon which way the wind is blowing. And of course, the Seneca Nation fishes in the Cattaraugus Creek. It's used as a recreation vehicle. And it's the plutonium and other alpha emitters are going to end up in the soil. And it may be 100 years from now, someone will contact that soil and ingest that plutonium. And so this once it gets out, it never ends. I mean, so we have to enclose these buildings to reduce the risk of escape. We really, and right now they're not doing it. And the reason that they're not enclosing the main plant processing building, according to Brian Bauer on February 28th, 2021, is that there's not enough people that live and work around the main plant processing building to justify the expense. And so he is writing off the people in West Valley. He's writing off the people in Springville. Because through their modeling calculations that the dispersal of the radioactive elements will not justify the expense. But if you look at it from the point of view of Dr. Gordon Edwards and the point of view of the lifetime of plutonium and the other emitters in soil, in the environment, I mean, it doesn't make any sense not to enclose the building. I mean, so we need to really push this enclosure. It's very, very important.
I could also follow up with the question had to do with where the radioactivity might land and who gets exposed. During the reprocessing, there were releases from that, even though they had filters on there were releases. And the researchers at the University of Rochester, Fenrow, and others decided to look at the presence of iodine-129. Now, there's a bunch of different iodine isotopes. The kind that they use in medicine and treatment and diagnosis are short-lasting iodines. But iodine-129, which is produced in the nuclear reactor, the short ones are too, but those decay away. The long-lasting iodine-129, it's got a 16 million year half-life, so it stays radioactive for 10 or 20 half-lives, so that's 160 to 320 million years. And so they decided that they would study this isotope because it is so long-lasting that it would still be there, and it would be an indicator of where other radioactivity might have fallen from the reprocessing activity. So in their report, they've got stations all around Western New York, and they compared the amount of iodine-129 in Western New York to other like nuclear power reactors. They don't have as much iodine-129. The iodine-129 is formed when the uranium splits, so it's in the fuel rods that got chopped up at West Valley. Well, at the reactors, those rods are generally intact. They might have pinhole pricks and releases, but they're not. At West Valley, they actually chopped it up and dissolved it and mixed it up. And so they have all this radioactivity that was actually no longer protected by the rod, the cladding of the rods. And there turns out that there was more iodine-129 found in Western New York in various locations, and that it was more than would have been seen in bomb tests. So these studies were interesting to look at, and it's an indicator that other radioactive elements may have also gone those same ways, but maybe they decayed or maybe they weren't detected because they weren't looking for those at this point. So you usually don't get one isotope, you usually get a whole bunch of isotopes. And so where they land, it depends on the wind and the water and the situation. The monitors that they have now around West Valley are chest high. They're at the 16 compass points, about a mile from the site. And they collect the filters and send them to the lab every few weeks or months. And they report in their annual report in September for the year before. So there's no other offsite monitoring. We won't have any idea what did or didn't happen until a year after it's over. And the level of the monitors, the wind roses that I showed the wind at 10 meters and then at 60 meters. So depending on where the stuff's released and how the wind is blowing, at different levels, it's going to blow in different directions with different amounts of strength. So it is hard to know even where to put monitors. That's a legitimate question. But if we put them in the places where we most are concerned, schools, wherever the people really want to know, is there anything coming here, and put it at elevations that would be likely to detect it, then we have a fighting chance of learning what's happening. And especially if there's no enclosure, something's going to get off the site. And we deserve to know what's getting off the site. And we deserve to have our state officials independently watch this as well, or have resources for other independent people to look at the information and to analyze it.
Great, thank you. And this was a question, I think someone had to leave a little bit early, but it's related to this question you just answered. So I'll jump to this one and then we'll go to some of the ones in the chat. So the question was around mobilizing people within that sort of radius of people who might be impacted. So obviously these sessions get to anyone within Western New York, but has there been any organizing or door knocking for any individuals within several mile radius of the site prior to this demolition?
Not that I'm aware of.
Yeah, I'm not aware of it either. So.
And the other thing is, when accidents happen, Fukushima, Chernobyl, 3 Mile Island, bomb testing, the radioactivity didn't just go 50 miles. The bomb testing in Nevada, the above ground testing in Nevada, the Trinity site, that went around the Northern Hemisphere and over and over again. So it's not going to stay put. I mean, yeah, it's probably going to fall more in our area, as Charlie said, with precipitation and depending on, but it could spread across New York. It could spread in the direction, could end up going in an unusual direction that's not the primary wind direction. So enclosing it would really give us a protection that would help prevent. There's going to be something released even with a shield, even with a tent over it. So if we were to make the effort to prevent the release, then less is going to get out. And there's not a safe level. That's another thing, that there's no safe level of ionizing radiation exposure. Any amount can increase our chances of cancer and reduced immunity and other diseases and other health effects. And women are 50% more affected. So the same dose to a man will, if it's given to females, 50% more women will get cancer than men will. And with children, especially little girls, the exposure, the damage to them is 7 times or more than it is to the standard man. The allowable limits were all based on what the industry was exposing its workers to and what the industry was releasing. They didn't decide, oh, this is something that would be a low amount of cancer. They decided this is what we have to do to operate legally. So if you look at the history of radiation protection, so the allowable limits, A, they're not necessarily safe, and B, they're not enforceable or verifiable. Millirems are a calculation based on some measurement of radioactivity, as if you know which isotope it is. because plutonium, cesium, strontium, they all do different things. So keeping it enclosed, monitoring for the radionuclides that get out, we feel is a minimum that our government can do. This is a government project, and both the state and federal government should step up, and we can encourage them very strongly to step up and protect us.
Great. And just a voiceover in the chat, because I know this is being recorded. It noted that Allegheny and Cattaraugus reservations of Seneca Nation of Indians are both within a 50-mile radius of West Valley, and to note that Fukushima was evacuated within that 50-mile radius. So just drawing those parallels between those two sites. Another question that we have in the chat is, have any follow-up studies been done on employees who worked at the West Valley reprocessing site?
That would be Ray Vaughn or Joanne, I think would be better to answer that.
Well, let me take one shot at it, and then I'm happy, very happy
Okay.
to open it up. So there's a worker compensation, EOSIPA, the environmental, the Energy Workers Compensation Act has been extended to workers from West Valley. These are workers who suffered health effects from their exposure. And so there's not been full, complete follow-up studies, certainly not of all of the sponges, the guys that were brought in, the people that were brought in to do a quick half turn of a screw and run out, but for workers. And I see Joanne has her hand up, so I will just defer to you, Joanne. You got to unmute.
I'm presuming I can unmute. Can you hear me?
Yes.
Okay. In 2009, my husband and I and Judy Einak met with 11 workers, all of whom had health problems and or cancer. What one of them found out was that NFS had conveniently lost his dosimeters and he was having trouble getting the compensation. I mean, I think that that's probably one of the realities that probably happened to other people too, you know, which I found that to be very depressing. But I just want to throw that out because I trusted this guy to tell the truth. You know, he ended up having to hire.
NFS is Nuclear Fuel Services, the company that did the reprocessing.
Right, and he worked with them, and then DOE, and he had worked there for quite a while. DOE dismissed him, you know, and he had to fight to get his job back because he was questioning the loss of his dosimeters. I thought, you know, it just was very depressing to hear, you know, and this is only one case, but I wouldn't be at all surprised if there were others that are similar. And I think the other thing too, West Valley started before we had the National Environmental Policy Act. And I think there are a lot of regulations where we have to really think about what we're treading on these days. And and I think they just didn't have the regulations to do the kind of work and record keeping that we expect today. It's not an excuse, but that's what happened, and I think that's what we're still dealing with. That we're still dealing with that situation. So, you know, I'll trip off here, but I think that one episode is really important. That it's a little scary to think that could happen, but especially with radioactivity.
Yeah, so it sounds like there hasn't been a more recent comprehensive study on any of these employees.
Yes, yeah, I agree.
Great.
I agree.
If there aren't questions, if you've got questions, great. If not, I do have a slide that shows plutonium in the lung. I could share my screen again, but if there are questions, let's continue.
Great. I was just going to say those are all the questions that we have right now. But as people are thinking of them, I'll share in the chat links to the 2 previous workshops. And then Diane, you're welcome to share the additional slides that you have.
Okay. Gotta find it. Here we go. Okay. And now I have to go back. Let's see. I'm going to go back to my radiation slides and just to summarize that ionizing radiation travels in waves and as particles, and it's more powerful than non-ionizing. And the two of the isotopes of big concern that we want to monitor for at West Valley would be plutonium, hazardous for 1/4 to 500,000 years, and iodine 129, as I said earlier, 160 to 320 million years hazardous. And I think people generally know these days that any level can cause cancer, birth defects, heart disease, reduced immunity, genetic damage, and other health problems. And just because it's a similar amount to natural radiation, it is in addition. And the different radionuclides concentrate in different parts of the body. Plutonium goes to the lungs, and radon goes to the lungs, iodine to the thyroid. Cesium goes to the muscle, and the heart is a muscle. And that could be why we've had seen heart problems around the children of Chernobyl. Women are, as I said earlier, 50% more susceptible to ionizing radiation than men. This has been shown in the National Academy of Science studies. And so this is the picture of lung tissue taken by Robert Deltradici, a photographer in Canada. And it shows where a plutonium atom in the lung is emitting and giving off damaging alpha particles to the lung tissue in the vicinity. So it doesn't go all over the place, but it sure packs a punch for where it is. And that's really just, Charlie mentioned the plutonium in the lungs, and I thought I should let you see that photo.
Yeah, that radiograph that Diane showed, that the limit of all that radiation coming off of all those alpha particles coming down off of that radon particle, is spread out just in that tiny volume. And
well, that was a plutonium. The one.
Plutonium. Sorry.
Yeah.
Okay. Yeah. Thank you. And maybe I'll steal that slide from you at some point. But yeah. So so it's very limited, and that's exactly the point I'm making. And that's exactly the point that the officials of DOE at West Valley are trying not to make. And they're saying that all that energy that's dispersed within that tiny volume is actually dispersed, throughout your whole body. And that's where they get that 10 millirem figure from. And they're doing it. That's by law. They can do that by law. It's legal to do that. But if you look
without
at
monitoring, there's no enforcement. I mean, they could say they do their calculations. These are the millirems and all these numbers.
Right, yeah.
Calculations to justify what they already want to do.
They're following the law, but the law is imperfect. And if you read that very, very simple explanation by Dr. Gordon Edwards in the link of my slide, you'll see that all that energy is really concentrated, and that's where the danger comes from lung cancer and so forth. And those are the kinds of things that we should prevent. And, we have to prevent the escape of particles, and we have to trap those particles that that do want to escape on plastic surfaces, you know, whatever it is, but they're better to reside on plastic surfaces that will be disposed of in a hopefully proper manner than it is to let those particles get out into the environment, where they'll remain until, you know, for the next 4 billion years. So, you know, how can you calculate the cost of the tent when the effect of not having a tent, you know, we pass down those costs for the next hundreds and thousands of generations. It's absolutely ridiculous. You know, we can't calculate the cost. It has no meaning, but we're passing those expenses down to succeeding generations, and that's unfair. I mean, we can do it properly now, and perhaps the succeeding generations won't thank us, but maybe we can tell them to thank us from our graves.
I just put the link in for people to send a form letter to governors and state legislators, but
Right.
we'll be putting a letter together for people to join us with a multi-group letter to these state officials in New York from organizations in New York in the next week or so. People to help out in that way.
Great. And I think that was a question folks had from the other workshops as well, is there sort of a hard date by which they're going to make this decision? Or are you just encouraging folks to complete this form letter as soon as possible? Is there a date at which it's too late?
Once they do the demolition, it'll be too late to have done it differently. We hear December, but we also thought it was going to be, I believe last November was at one point the time it was going to happen. And then it kept getting, you know, COVID intervened, and the other accidents at the Hanford, they had to incorporate those lessons. And so we don't know. I mean, things always, and there's also going to be more. This is one step in a much larger cleanup at West Valley. This is a huge, huge project because this is one of the most radioactive buildings in the weapons and power complex. It's coming down, but there's also enormous amounts of radioactivity under the ground and elsewhere on that site. And so when they're digging up the trenches, when they're digging up the tanks, when they're digging up the federally NRC licensed burial ground that has irradiated fuel in it from the weapons reactor at Hanford, we're going to want enclosures and monitoring then too. So I think we need to set a good precedent here if we can with this demolition. It's too bad we couldn't have done it before the vitrification building came down, but we have until we have. So people should continue and make direct contact with your officials and be in touch with us if you would like more information.
Great. And just to voice over what's in the chat too, it's just that education about the danger of nuclear exposure, especially in Western New York, is needed in order to update the public thinking that people sometimes think that nuclear is a clean energy option. The nuclear energy industry makes more and more money as this type of contamination increases, but with both old and new sites. So just to say that, how do we change public education about this, or that more of it is needed?
Well, the issue of spent nuclear fuel is the Achilles heel of nuclear power. I mean, if there wasn't any spent nuclear fuel, if we, we wouldn't be talking about this tonight here. And so unfortunately, we don't know how to turn off radioactivity. Once we make it, it's going to go through whatever process that it will go through for 10 minutes or 10 billion years. So depending upon the element. So, I mean, the issue is the only thing we can do right now is not to make any more of it. And we're going to have to figure out how to deal with the spent nuclear fuel that we do have, because it has to be kept in a safe manner for, safe from succeeding generations, So the only way to do that, I think, and we've talked about it among ourselves, and I think we've come to the consensus that the only way to do it is to have on-surface storage in a building, and the casks that store the radioactive material have to be rebuilt every 50 years or 100 years or 150 years. And those timings are well known. And so, for example, the casks that are sitting on the pad at West Valley are going to have to be rebuilt in another 30, 40 years. And they're already through, along their way on their life cycle. And wherever they are in 30 or 40 years, they're going to have to be rebuilt. Now, if you put that underground, such as the WIP, waste isolation storage area.
Pilot plant.
Yeah, thank you. And then it's the risks being forgotten, and you don't want that, because once the radioactivity gets out, it gets into the environment, and it will eventually reach the surface from WIP. The rain water will eventually get down there in thousands of years or whatever. So we have to figure out a way of educating succeeding generations of people about the dangers of radioactivity. And we have to make sure that the technology that that's available can rebuild those tasks, to keep succeeding generations safe from radioactivity. I'm not sure that we have the political structures in the world that will maintain, control of this material. We elected an official here, in 2016 that's incompetent. So that's going to happen again in another 150 years at least. Where someone of power may decide, how dangerous radioactivity is, and may decide that it's perfectly fine. So those risks are going to happen, but if we put it underground, it will definitely be forgotten, and at some point in the future, beyond that, it will come back to the surface to haunt people again. So surface enclosures are the only way of keeping this stuff safe. So.
On the not making more. I mean, obviously.
And not making more, right.
Well, I was going to say on not making more that unfortunately, both the Department of Energy and the Congress are hellbent on more nuclear electricity and keeping old jalopies of reactors that should have closed years ago continuing to operate. New York, of course, is bailing out the older reactors in New York, keeping them running. Now in Congress, the infrastructure bill, the energy bills that are being discussed in the Senate are subsidizing nuclear power, and more so than the real renewable solutions to climate change. They're stealing the money for real solutions to climate change and funneling it into nuclear power, both old nukes and subsidies for new nukes. And we have several alerts on our website, nirs.org, and then if you click on the action and then on the alerts, you can scroll down and see which alerts are to your Congress members to oppose subsidizing more nuclear, because you can't make nuclear power without making nuclear waste. And that's what we've stuck with at West Valley, and we have to deal with it. But making more, we can prevent.
Great. So I know we're at our time today. I just wanted to thank Charlie and Diane for giving that 7-generation outlook, both before, right now, and moving forward. For those of you who did not see, we have some resources and links in the chat for the next conversation on August 24th. We invite you to register and participate and invite anyone to attend there. We will upload the slides, and I know Charlie referenced a couple links from his slides. So we'll have all of these resources available. We'll put them on our site. I know Western New York Environmental Alliance, as we linked to, has the previous recordings on their Facebook page, but we'll put all of this together in one place so that people can access these materials and the previous ones. If you have any questions, you are welcome to reach out to me. I will put it in the chat. It's buffalocommons@cornell.edu or ks844@cornell.edu. I know Diane has provided her information elsewhere, and we'll also put it on our website. But thank you all for joining us this evening, and we look forward to talking to you again soon.
All right, thank you.
Thanks all. Thank you for coming.